Welcome back. Sorry about that. At the end of the last video, Zoom crashed right in the middle of this example, so part two. So I'm going to restart this example because I don't know exactly where it cut off. So here we're solving p plus 8 less than negative 10. We're going to answer that using interval notation. So again, here the unknown had 8 added to it, and so we're going to solve for p by subtracting 8 from both sides. So this will give us just p on the left side and negative 18 on the right. P is less than negative 18. In interval notation, that'll be negative infinity up to, but not including negative 18. All right, so in short, if you have an inequality, you can add or subtract the same amount on both sides, and that preserves the inequality. Before we go on to our other property, I wanted to mention that for equalities, we saw that, yes, you just add or subtract the same thing on both sides, and that was it. For this one, I've stated this inequality for a less, or the rule about inequalities for a less than. This is still going to be true if I make it less than or equal, or greater than or equal. I just didn't want to write this down 4 times. Once for less, once for greater or equal, and once for greater, right? I lost track. So point is, keep in mind that there are basically 4 of these rules, but the principle is still true, that if you have 2 numbers in order, one's less and one's greater, that you can add or subtract on the same value on both sides, and it preserves the order. But keep in mind that it doesn't matter if it's less, greater, less or equal, or greater than or equal. You still get that same effect. Okay, so let's go on to the division and multiplication properties of inequality. And this one is a little bit more complicated, and it has something in it that we're going to have to be careful of, and it's a little longer. So again, keep in mind that this rule could be written out 4 times. Once for less, once for greater, once for less than or equal, once for greater than or equal, but we're not going to. Just keep in mind that it's there. We're going to state it all for less than. Okay, so there's 2 parts to this, really. For any numbers, a and b and c is bigger than 0 for this. If a is less than b and you multiply by c, ac will be less than bc. Or if you divide by c, ac will be less than bc. So that's the same as before. If you have a is less than b, you multiply by c or divide by c, and it's just as you would expect. If the c is positive. The part that is different, and the piece that you have to be careful about, is that if you are multiplying or dividing by c and c is negative, okay, notice that that's a less than sign on RC. If that's less, then notice that the direction on the inequality sign changes. Where originally we had a is less than b, when you multiply by c, you now have ac is greater than bc, and a divided by c is greater than BC, so greater than's, okay? If the C is negative, if A is less than B, and you multiplied by a negative or divided by a negative, the direction on that inequality sign switches. Okay, so that's what the yellow highlighting says, and that's the one thing that you really have to be careful of here, and so we'll just practice that. Okay, so let's try that right here. So here we're going to solve each of these. We're going to answer using interval notation. So here 3x is bigger than 18. We would divide both sides by 3. 3 is positive. There's nothing to worry about. X is bigger than 6. So we have 6 up to infinity. And that's it. Okay, 4x is less than or equal to negative 24. We're going to divide by 4. 4 is positive. So we'll have x is less than or equal to negative 6. I know the negative 24 is negative. That's fine. It doesn't matter. What matters is what you were multiplying or dividing by. In this case, we're dividing by the 4, which was positive. So everything's fine. X is less than or equal to negative 6. Negative infinity up to and including negative 6. Okay. Next, negative 7x is bigger than positive 28. For this one, I would divide both sides by negative 7. Since we're dividing by a negative, it'll switch from greater to less. And instead of 28, we'll now have negative 4. We switched from greater to less because we divided by a negative 7. That will give us negative infinity up to -4. Okay, negative 10x is greater than or equal to negative 140. Dividing through by negative 10 will give us x is less than or equal to 14. Again, I've turned around the direction on the inequality sign because that 10 was negative. That was a negative 10, so we turned the thing around. The fact that the 140 negative, that was negative, that doesn't enter into it. What matters is what you're multiplying or dividing by. That's what makes a difference. Okay, negative infinity. Sorry, pen stopped. All right, sorry about that. So here x is less than or equal to 14. That will be negative infinity up to and including 14 for that. Okay, 1/3 of x is less than negative 20. We'll multiply both sides by positive 3 to give x. Okay, so this will give us x is less than negative 60. Okay, because we multiplied both sides by negative 3. Okay, so now x is less than negative 60. That will be negative infinity up to, negative infinity up to negative 60. All right, and then now for this next one, we have negative 2/3 of x is greater than or equal to 10. So we're going to multiply. We could look at this as multiplication or division. We're going to multiply both sides by negative 3/2. So negative 2/3 x times negative 3/2. So let me make it clear what we're doing. We're multiplying by negative 3/2. So negative 2/3 times negative 3/2 will give us 1. Because we're multiplying by a negative, this will switch from greater than or equal to less than or equal to. And then we'll have negative 3/2 times 10. So we'll have x is less than or equal to negative 15. So that's negative infinity up to negative 15. All right, last one, we have negative 1/5 y is greater than 6. I've done a lot of greater than, so let me make this one less, just for variety's sake. So let's change that around. All right, so we have negative 1/5 y is less than 6. So we're going to multiply both sides by negative 5. So this will give us y, and now that will be greater than negative 30. Because we've multiplied by a negative. So negative 30 up to positive infinity. Okay, so hopefully that is clear. If not, let me know if you have any questions. As we work through these linear inequalities, if we need to do some simplification, it's going to be the same sort of sets of steps as we'd had in working on equations. That is, if you need to distribute to remove parentheses, combine like terms, multiply both sides by something in order to clear a fraction, all that kind of stuff is going to be the same. The one thing that we need to be careful of is if we ever multiply or divide the entire inequality, both sides, by a negative, then we need to change the direction on the inequality sign. All of the rest of the stuff is going to be pretty familiar. Okay, so here for this one, we've got 8y plus 3y minus 12 is greater than 7y minus 28. Our first step is going to be to distribute that 3. So we'll have 8y plus 3y minus 36. That's greater than 7y minus 28. Okay, then let's combine like terms. We'll have 11y minus 36 greater than 7y minus 28. So now for this one, we're going to need to collect the variables onto one side. So I'm going to collect them on the left side. So we'll be subtracting 7y from both sides. All right, so then that's what we've got up to this point. We're going to subtract 7y from both sides. This will give us 4y minus 36 is greater than negative 28. Let's add 36 to both sides. We'll have 4y is greater than 36 minus 28. So 4y is greater than 8. So far, it may as well have been an equation, not even an inequality, because we've done the same steps as we would have, distributing to remove parentheses, adding and subtracting the same thing on both sides. I've got to divide by 4 here to finish this thing. Fortunately, 4 is positive, so we don't have to worry about changing the direction on the inequality sign. Get y is greater than 2, so that's 2 to infinity in interval notation. Okay, next up, let's try this one. For this one, why don't you pause the video, try it yourself, and then restart the video and see how you did. All right, so here we're going to first begin by distributing to remove parentheses. We'll have 4b minus 3 times 3, that's negative 9. Negative 3 times b, that's plus 3b. Pause for a second there. Now, you'll notice that we multiplied in here by negative 3. We distributed that negative 3. I'm not going to change the direction on the inequality sign because I didn't multiply both sides by a negative. Here, we're just distributing a negative into some parentheses. I didn't multiply both sides by that negative. Okay, so now we'll have 5b minus 30 plus 2b. Combined like terms, 4b plus 3b is 7b. We have 7b minus 9. On the right side's 7b minus 30. Okay, so on this one, we have 7b minus 9, 7b minus 30. Let me subtract the 7b from both sides. We have negative 9 is greater than negative 30. Okay, so when this happens, you notice our variable is gone. This means one of two things. Either I've made a mistake someplace, which you can check. We'll check here in a second. Or when you end up with a statement that is always true, you remember from our equation section what that means. That means that it's going to be all real numbers for the solution. If you want to write that in interval notation, that'll be negative infinity to infinity. So that will be one option or one possibility. The other possibility is that I made a mistake. So let's check and see if that was the case. So we have 4b minus 3 times 3 is negative 9 plus 3b, 5b minus 30 and 2b. Nope, it looks pretty good. So our solution there is just all real numbers. If it had come out something that was always false, then that would have meant that we had no solution. Okay, here's one where we have some fractions in it. How we dealt with fractions in the past was multiply both sides by whatever it takes to make those fractions go away. So the LCM of the denominators, 4, 12, 6, and 8, is going to be 24. So we're going to multiply both sides by 24. 24 is positive, right? So I don't have to worry about multiplying. If I multiply by a negative, I have to change the direction on the inequality sign. Because I've multiplied by a positive number, everything is okay. Okay, I was talking while I did that, so let me make sure I didn't mess anything up. 24 times 1/4 x minus 12 x. I got the greater than sign. 24, 1/6 x, and 7/8. Distribute the 24. 24 times a fourth is 6. 24 times a 12th is 2. 24 times a sixth is 4. And 24 times 7/8, that's going to be 21. Okay, fractions are all done. We're going to collect the variables onto the left side this time. So I'm subtracting 4x. That'll give us 2x minus 2x, and then a 21 on the right side. So here we have 0 is bigger than 21. Well, there you go. There's our one with no solution to it. Okay, 0 is never bigger than 21. So there's no solution on this one. All right, so that takes care of that. I expected something nicer, but no solution's fine. Okay. All right, in the last part, we are almost done here. In the last part, we're going to be translating some inequalities from English into math and then solving. Okay, so here it says 20 times y is at most 100. So at most would be anything up to or including less than or equal to 100. At most is up to and including less than or equal. So we'll divide through by 20. Y is less than or equal to 5. In interval notation, negative infinity up to and including 5. Okay, 19 less than W, so that'll be W minus 19. is no less than 47. No less than means it's got to be at least 47. Greater than or equal to 47. Okay, you could think of what would less than mean. And then if that's not true, the no is in there. If it's not true, that it's less than 47, it has to be greater than or equal to 47. Okay, that takes practice, I know. Okay, 47 plus 19 is going to be 66. I have a greater than. Let me fix my writing. W is greater than or equal to 66. We have 66 up to infinity. Okay. 8 times z is smaller than negative 40. So here we're going to need to all right, let me try that again. 8 times z is smaller than negative 40. We're going to divide through both sides by z, which is positive. So we'll just have negative 40 divided by 8, which is negative 5. Z is smaller than negative 5. That's negative infinity up to negative 5. Okay, last one. Half of k is more than 12. Okay, so if half of k is more than 12, we're going to multiply both sides by 2, which is positive, so everything's fine. K is bigger than 24. All right, so that will do it for this section. We first looked at interval notation, which is a way of describing chunks of the number line. We saw that you use a parenthesis or square bracket, depending on whether the endpoints are not included or whether they are included. And we talked about how you always use a parenthesis with infinity. And then we talked about the two rules, essentially two rules that you have for working with inequalities. You can add or subtract the same amount on both sides of an inequality without changing the ordering. Whatever's less stays less, whatever's bigger stays bigger. If you multiply or divide both sides by a positive, same thing, the order stays the same. The one thing that you have to be really careful of is if you multiply or divide both sides by a negative, then the direction on the inequality sign switches. Okay, so that's it for chapter 2, really. Let me know if you have any questions, and have a great day.